Good morning. I see that we already have a few participants in. We'll be waiting for a few more minutes and we will start this webinar at 2 p.m. Singapore time. Thank you. Good afternoon, everyone. So it is now 2 p.m. Singapore time, so we shall be starting with our webinar. Thank you very much for joining us. So my name is Arno Panini, and I'm the market manager for Bossa Asia Pacific in Singapore. So for the next 45 minutes, we will be covering some of the fastening solutions for sheet metal assemblies. So before we start, I would like to request everyone to please mute the microphone. Ensure that you can visibly see the screen, and if not, raise your hand or ask a question in the dashboard. And I'd like to let everyone know that this session is being recorded. If at any time of the webinar you have a questions or you would like to raise your hand, please do so, and I'll be stopping at some points to address your questions. Thank you. So what is the agenda for this session this afternoon? So as I've mentioned, we'll be looking at some of the fastening technologies for sheet metal technologies. but we'll also be looking at some of the innovative solutions that recently came out in the market, both in terms of the products, the fastener themselves, but also in terms of the installation equipment. We'll be taking 2 breaks along the presentation, during which I will test your knowledge in the form of a quiz. I see that there is already a hand up, Mr. Mark August. If you would like to either ask questions, you can just go ahead and unmute yourself. Okay, so I'm just going to assume that there is no question. Go ahead and lower the hands. If there is, please ask a question in the question box of the GoToWebinar dashboard. Thank you. So what are the motivation of the session this afternoon? Why are we taking 45 minutes? Some of the questions that our customers generally ask is, what are the fastening technologies for sheet metal assembly and how many solutions do I have? Well, it very much depends. For example, on this type of application, it depends on whether you are trying to join edges together, whether you are trying to run cables inside the box, or if you are trying to fix other elements within the box. If, for example, you are joining 2 sides of the panel together, you might want to use either thread forming screws, set pinching fasteners, or riveting technology. Once you've chosen the technologies, other solutions are offered to you in terms of which installation equipment is the most suitable for the application. Another motivation for the webinar this afternoon is, why do we even care about fastening technologies? Sometimes fasteners are overlooked as they seem quite simple. Here is what might happen if you do not properly select your fasteners. It can very easily fail. This photo was taken from one of our customers 3 years ago, and the process was not accurately controlled, which had the effects of breaking the fasteners when the torque was applied over it. Another example from one of our customers is this PCB plate on which the wrong fastener was selected, and it left a very visible mark over the surface, and it also bent the PCB downward. What could also happen is that the threads of the fasteners might fail, or the nuts can be stripped away. Hence the importance of always properly select the right fasteners for your application. Now, what technologies are we going to be reviewing this afternoon? So we'll be looking at 5 broadly used technologies. The first one is direct assembly. Second, panel screw, third, self-pinching, and riveting, and also stud welding technologies. But more than just the basic technologies, we'll be looking at some innovative solutions in the form of new fasteners, spot fast, FDS, some installation equipment, and also a new technologies for stud welding that goes by the name of SM. But without further ado, I would like to start with our first technology, which is spot welding and direct assembly. So the way spot welding works is with 2 copper anodes, which are then pressed onto the panel. An electric current is then passed through between the 2 anodes, which forms a small weld nugget. With the pressure being applied on the copper anodes, it then joins the 2 panels together. It is a welding process that is characterized by very short welding time. We're looking at 10 to 100 milliseconds, and there is no heat applied in the remainder of the sheet. It's only localized here at the junction of the 2 panels. It is widely used for welding of carbon steel nuts and also for junctions of 2 or more panels. In terms of the material on which it is used, carbon steel and aluminum, and the automotive and consumer appliance industries are heavy users of these technologies. The equipment cost, as it is pretty common in the market, it is now fairly inexpensive to acquire. It's pretty cost efficient and it gives a good strength when it is done right. So I've mentioned here done right because you have quite a few parameters to input when using this technology. That can be difficult to control. If too little energy is applied, there will not be enough melting, which will then result in a poor weld. If, however, too much energy is applied, what can happen is that it will create a hole through your panel. It tends to harden the material and cause it to wrap quite significantly if it is on a very thin piece of panel. And because of the electric current being applied, it reduces fatigue strength and it can also stretch the material and invite rust, as shown on this photo here. Finally, no dissimilar assembly is possible, only carbon steel on carbon steel or aluminum on aluminum. So what other alternative would we have to try and replace spot welding technology? So one that I would like to introduce this afternoon is called spot fast. Spot fast is actually a fastener that is pressed into the panels. In the case of spot welding, you will see here a very visible burn mark on the two faces of the panel. With spot fast, the panels are drilled and then the fasteners is inserted into the hole of these two panels. And as you can see, the end result is pretty clean. It provides for a flush assembly with no visible mark. It can be used to join metal to metal, similar to spot welding, but it can also be used on dissimilar assemblies, on metal over plastic, or even on PCB over plastic. No contouring hole is needed or other treatment. It can be installed in a blind setting, or it can also be installed in through application. Very simple process to control, as there is only one single setting, which is the force, and it provides flush and, as I've mentioned earlier, clean joints with no burn marks. Now, the second technology that I would like to review this afternoon is direct assembly screws, also called thread forming screws. So how many types are available and what are the differences between those types? So very broadly, we can categorize into three main categories. The first one is self-drilling. In the case of self-drilling, no pre-hole is required. When the screw is driven into the material, it will cut its own hole and it will also cut its own matching threads. The second category is the thread cutting screws. On the top right side of the panel, you will see here three cross sections. On the left-hand side, you have the cross section of a standard screw with a nut, with a small gap between the two sections. Here, in the middle, you have the cross section of the thread cutting screws. In that case, there is a need to drill a hole, but there is no need to tap a thread. The thread will be cut into the material as the screw is driven. And the last category, which is widely used on soft material, will now not cut the thread, but what will happen is that the thread will be formed into the matching part. So why is this important? Because if you have an application that is subject to vibration, by this effect of forming the threads, it will create no play between the matrix thread and will therefore be suitable for anti-loosening applications. So panel screws generally used on soft material of a tensile strength of up to 510 Newton per millimeter square. Therefore used on magnesium or aluminum die casting, on white good, plastic housing or various machineries. And there is no equipment required. Equipment cost is close to zero. Now, what are the most widely used thread forming screws in the industries? Three main types: sheet track on thin panels, alt track for increased clamp load, and also dual hard tip on hard materials. And very recently, a few years ago, a new innovation came out in the market, that is the FGS screws that we're going to be looking at. So just wanted to introduce the more commonly used type of thread forming screws on panel, which is the sheet track. So the sheet track is used to join thin sheets from 0.5 to 1.5 millimeter. It does exhibit high strength, and as I've explained earlier, it is suitable for high vibration assemblies, and the assembly is fairly simple. Now I would like to show a very brief video that explains this screw a little bit further. In here. Okay, so I think it was pretty obvious from the video the thread forming process and how the thread is actually formed into the panels. So for the subsequent screws, for the sake of time today, since we do not have much time, I will not get into the details of all those various panel screws, but what I've prepared here is a handout which is available in the GoToWebinar platform that you can download. And on this handout, you will have all the information, all the basic informations about those alternative solutions for panel screws. Now, what I would like to introduce is a pretty new type of panel screws that goes by the name of flow drilling screws and provide unique features, which was released in the market roughly 4 or 5 years ago. So to introduce this technology better, I would like to broadcast a quick video about it. Okay, so the video showed an example of the FGS apply on a letter, but it's also very widely used for any type of high volume applications. Automotive is one of them, where you have to assemble panels and you require very high vibration requirements working with high strength steel, or when you need a very high loosening torque. It is a breakthrough technology because this is the only type of panel screws that can actually be automated, does not require a pre-hole, and actually form a thread into the matting material, and that can also be removed, so which is also usable for maintenance purpose. So we'll be moving on to the third sheet metal technologies for this webinar, which is a self-clinching technology. So a little bit of history about this technology. It's actually not a new technology, as the first patent was filed in Germany at the end of the 19th century. But it fell out of favor and the industries did not really start using it all the way until beginning of the 80s in Germany with Audi, during which the building of the car used this technology very extensively. So I'll give you a little primer on this technology. It can either be used to permanently join panels together, similar to the spot welding technology we covered in the beginning. So a punch would press the two panels, which are held by a die. Through applying pressure between the two panels, an interlock will be formed, which would then permanently join our panels together. Self-clinching technology can also be used for non-permanent joining through the use of a nut. It's also a cold forming process during which the nut is punched, or rather pressed, onto the panel, and the panel cold flows into the nerves of the nut here, and the screw is run to assemble the panel. Now, self-clinching technology was designed for thin panel. There is no rework necessarily, and height strength can be added up to 10.9. It has very low energy cost as compared to welding technology. It can be used on zinc-plated or even galvanized panels. And there is a wide product range for this technology, from nuts, studs, standoff, and so forth. Now, three main limitations that I wanted to point out of this technology. First limitation is the minimum distance from the axis of the fasteners to the edge of the panel here. If the fasteners is positioned too close to the edge, what will happen is that the edge here will actually bend up, will bulge out because of the pressure applied by the punch. Another limitation is the maximum panel hardness. I mentioned that it is a cold forming process. Therefore, the material must be softer than the hardness of the fasteners so that it can actually cold flow into the fasteners. And the last limitation is panels, which are too big for handling in case you are not using automated setup and you have operators needing to handle the panel. Now, I would like to introduce two new products that were released in the recent years in this technology. The first one is to actually facilitate box making. And the second one is to improve spacing and also improve maintenance access. So let's look at them one at a time. So when you are building a box, when you are assembling two panels with a 90-degree angle, or when you are assembling dividers inside the box, you would need to have bent edges, or you would need to use angle brackets. which can be quite time consuming and it can be quite wasteful as well, as extra material is needed to join the two faces. Now with these solutions, a small cutout is required in the panel and the fasteners is then clinched through it. And the side panel is then assembled directly with a 90-degree angle onto the wrangle. So that way, no bent flanges are required and no additional angle brackets are required either. Now, if you want to space out two panels, what is generally used in the industry is a combination of a standoff and a screw. So the standoff is assembled onto the bottom panel. The top panel is positioned over the standoff and the screws is used to hold the assembly together. But if you are looking for something a bit more maintenance friendly or a bit faster, what you could consider is a snap top clinching item. So with the snap top, it is clinched onto the bottom panel and the top panel will then be manually inserted by hand into the snap top elements. And it can then be removed just by pressing here at the bottom of the panel and applying a force upwards to work it out of the snap top fasteners. So in that configuration, no screw is required. Now, what about the installation of the fasteners? What kind of tools are available for this? New product lines that came out last year is Hager. Hager is not new in the market, but they just released the 5th generation of their self-clinching machines, which I would like to introduce today. So for this, I've prepared a video showing an overview of this product line.
The 618 and 824 MSP brings you the advantage of having the new optional MAS 350 auto feed. The larger capacity bowl design allows for the insertion of fasteners up to size 3/8 or M10. Multiple part handling in the fastener insertion area can be eliminated with this multi-station press that combines the PLC touchscreen with electronically controlled hydraulics and the turret insertion system, allowing the insertion of more than one type of fastener in one single workpiece handling. The 618 MSPE increases productivity up to 70% over the legendary 618 Plus. The Window Touch 4E includes many new features designed to increase operator efficiency. Some of these include quick and easy tool retrieval, 3-second tool change on the bowl feeder, pre-aligned shuttle platform with integrated air and sensor cable connectors for quick disconnect and reconnect of the shuttle, turret insertion system version 3, and full process control in Station 1, including fastener detection, fastener length detection, and insertion mapping. The OneTouch 4E Lite brings you the advantages of the 824 Window Touch and the productivity of the OneTouch by allowing automatic feeding of 2 different types of fasteners in one single workpiece handling. Some features include easy-to-use insertion logic software, increased productivity of up to 30% over the 824 Window Touch-4, while implementing full process control in 2 stations through fastener detection and fastener length detection, and the dual automatic upper station, which changes the upper tools and insertion stations automatically. The 824 OneTouch 4E includes many time-saving new features, such as automatic feeding of 4 different types of fasteners in one single workpiece handling, increased productivity of up to 50% over the 824 Window Touch-4, while implementing full process control in all 4 stations through fastener detection and fastener length detection, tooling which mounts on the outside for easy access. All bowl controls are integrated within the insertion logic software, quick and easy tool retrieval and shuttle plate mount, automatic loading of lower tools, and 3-second automatic tool change. All of our Dash 4 machines come standard with our quick change tooling, which virtually eliminates any alignment or setup during changeover. Tooling changes can be completed in less than 3 minutes, and all bowl controls are integrated within our insertion logic software, eliminating the need for operators to adjust bowl settings during setup. The 824 One-Touch 4E XYZR is a 4-axis, fully robotic system combining the highest productivity with process control. Up to 6 MAS 350 autofeed systems can be installed, allowing the insertion of up to 6 different pieces of hardware in one single pass on both sides of the workpiece. The XYZR offers 0 errors in the hardware insertion process, as well as unmanned production time of up to 8 hours, depending on workpiece size.
Okay, so yes, I wanted to show that video that gives a comprehensive overview of the entire product line, from the very simple, I would say, requiring an operator to handle type of equipment, all the way to the fully automated rig with no need for operator interactions there. Okay, so we've gone through already quite a fair bit of material, so I'd like to take maybe 2 or 3 minutes and let's see if you've actually remembered everything that I've said up until now. So we're gonna go ahead and test your knowledge through a poll. So I've prepared 2 questions which I'm going to release now. So I'm gonna go ahead and release the first question for you to answer, which will show up on your screen. Okay, so now you should see the first question popping up. So I'll be waiting for 1 or 2 minutes for you to answer. So what type of panel screws prevent loosening? What did we discuss? Are we looking at self-drilling, thread cutting, thread forming, or thread making screws? Which one actually prevents loosening? So I'm gonna be closing the poll in a few seconds if some last answers can come through. Okay, so I'm gonna close the poll and give the answers to that question. Okay, so as per our discussion, the only type of screw that prevents loosening is actually the thread forming screws, because the matching thread is formed into the material and not cut. Now, one more question which I'm going to launch right now is, what is not a limitation of the clinching technology as per our discussion? Is it maximum panel harness, installation and pre-plated panels, or minimum distance to edge? I'm gonna be waiting for another 10 seconds or so before closing this poll. Okay, so I'm not going to close it and give the right answer. Okay. So as per our discussion, what is not a limitation of clinching technology is the installation in pre-plated materials. We talked about 3 limitations: minimum distance to edge, maximum panel harness, and panel which are too big for handling. So now we are moving on to our 4th technologies for this webinar, which is the riveting technology. So how many various types of rivets are in the market? Are we looking at just a few or maybe a dozen? Well, in fact, four main categories are available in the market. The first category, which is the first one that was invented, is the solid type of rivets. One very good example of the solid type is actually on the Eiffel Tower. So the Eiffel Towers is assembled with 2.5 million rivets. And how they were set back in the days was by using 3 persons. One person at the back to hold the rivets, another one which would first preheat the rivet and then bang it in place to form the head of the rivet. So 100 years ago, it would actually require 3 persons to assemble only one piece of rivet. Now, the second category, which is, I would say, an enhancement of the solid type, is the tubular type. This time, the section of the rivet is hollow so that you can gain on weight. For example, used on leather and is installed with an orbital riveter. The third type of rivet is the split rivet. So the split rivet is generally used on very soft type of material, for example, leather or fabric or plastic material. And finally, the last type of rivets, which is probably the one you are familiar with, is the blind type of rivet. So in terms of the blind rivets, you can come across 2 types: the non-structural rivets and the structural rivet for more heavy-duty type of application. A cross section of the rivet shows that it's actually a 2-part component with a head and with a mandrel. What happens when the rivet is assembled? The pulling head will grab the mandrel and pull it upward. There is a small notch at the bottom of the mandrel to weaken the section, so that when it is pulled upward, the rivet will always fail in that particular section here, and then the mandrel is taken away and dropped out. Rivets are characterized by 2 types of strengths: horizontal strengths through shear and vertical through the tensile strengths. In terms of the tooling, if it is low production runs, hand tools can be used, or if it is a bit mid production run, I would say pneumatic or hydropneumatic tools generally used. But now, what if you are looking for higher production rate? What's available in the market? So we'll be looking at 2 technologies. The first one is the speed rivet technology, and the second one is a fully automated type of setup for assembly of rivets. So taking the speed rivets as our first technology, here is the classic brainstem rivet, and here's the type of rivet that is used with speed rivet. So as you can see, it only has a head with no mandrel. And what happens is that this head is mounted into a loading mandrel here, which is then inserted into the installation gun. Up to 100 pieces of rivets can be installed onto one installation mandrel. As you can see on this animation, the mandrel is inserted into the gun, and then the rivet is pressed onto the 2 panels to join them. And it is obviously significantly faster because you would not need an operator to manually reload the rivet one at a time into the gun. Here's an overview of the installation equipment, either handheld installation equipment of this type, can also be semi-automated on a bench. In this case, the panel will have to be positioned, and then a press pedal is actuated to set the rivet. Or in this kind of setup, here is even fully automated, where the panel only needs to be positioned over the setup. Now, if you are looking for a completely automated solution, you would have one other type of solution, which is automated riveting production gun. In this case, there is a vibratory feeder into which the rivets are fed. Then, through hoses, the rivets are blown to the gun here and then set onto the parts. So in order to illustrate this maybe a little bit better, I have inserted in a video which I would like to share with you. So as you've seen through the video, it is for high production run when really the speed is paramount. So in that case, the rivet is not inserted, but it's blown through the holes and brought to the actuation mechanism of the rivet gun. And it can also be fully automated with no need for an operator to robots. One good example of this is Huawei in South China, for which you can see photos inside the factory that use this type of riveting equipment. Now, the last technology we are going to review this afternoon is stud welding technology. First, what is stud welding and on what type of application is it used? Stud welding can be this, can be a thread assembled onto a panel, but it can also be this. It can also be shear connectors installed onto bins for a concrete slab to be poured over it. But so how did this technology come about? It actually came about in the late 40s as part of the American World War effort. At that time, they were building ships, and how they would assemble wooden deck onto the ship would require to drill the decks, which was a very lengthy and cumbersome process. So the stud welding technology was actually used so that the wooden deck could be assembled directly without any need for drilling of the deck here. The pioneer of this technology is the American brand and the leader in the market, Netson. Two main types of stud welding technology: capacitor discharge and arc welding. So you have the two technologies here on the right-hand side for us. The top one is the drone arc technology. As you can see, the quality of the weld looks a lot better than for capacitor discharge. This technology is generally used for high-strength applications, but it will leave a visible burn mark on the back of the panel. Capacitor discharge studs, three things to remember. It's an extremely fast technology used with small diameters and can be welded on aluminum and also copper panel. Whereas with the drone arc technology, mostly used for high strength application with bigger diameter, and this time another element is needed, which is a ceramic ferrule that we see here, which contains the molten welds into this area. Now, here's very brief overview of some of the application for capacitor discharge: copper panel, aluminum, stainless steels, or enclosures, where the cosmetic is actually important for the application. And where cosmetic is not important, but strength is vital, drone arc technology should be used, for example, on highway or switch gearbox or this type of roller plates here. Now, these technologies are pretty old technologies. In fact, I mentioned they were invented late 40s. So is there anything new that has been brought in the market? In fact, 4 years ago, a new revolutionary technologies was released, which is the stud welding with rotating magnetic field technologies, for which I'm going to show a video.
The valiant little welder. There are those who claim there is a new welding method. There are those who claim there is none. But we say SRM is a new method. Once upon a time, in a faraway place, there lived an honest, hard-working locksmith who spent all his days slaving in his workshop. He had to spend all his time welding, and as he didn't know any better, he used an age-old welding method. Day in, day out, he worked away without ever complaining, even though the work was cumbersome and dirty. The heat was sweltering. Sparks showered and smoke belched around him. It was loud and stank, and those dreaded ceramic rings, unwieldy and so very hard to clasp, they became so hot and caused so much dirt. The little locksmith, however, was happy with his lot, even though at times he secretly wished that his life could be a little easier. And look, his wish really did come true. A clever, resourceful stud welding manufacturer came up with a new welding method called SRM, which was light years ahead of its time. Everything is so simple, quick, and clean as a whistle. A short hissing, and look, the stud is already positioned. From then on, the little locksmith lived happily ever after. And if by chance he is alive to this day, then you may be certain he's still welding with SRM. And perhaps in your town, there's also a hard-working locksmith who is dreaming of a better weld.
So this technology as shown on the video is called symmetrical rotation magnetic because it uses the power of a magnetic field. So what will happen when the electric arc is ignited, the electric arc will be guided in a rotating way with the magnetic field here. So that's the secret and the enhancement of the technology. Previously, the electric arc is not guided, so it would pretty much go any directions with no rotation here over the stud. So the advantage of using this is that it can evenly melt the stud and evenly melt the panel here for a very clean and high strength fusion weld. And since this technology enables the electric arcs to be guided, hexagonal nuts can also be welded with this technology. So this type of nuts can only be welded with SRM and not with drone arc or not with capacitor discharge technology. Okay, so we've reviewed the 5 main technologies that I wanted to cover today. The objective was to increase the process, increase product efficiency, to spot fast, to new type of panel screws, also to increase production time with better installation equipment and fasteners that can be automated, reduce the cost, improve quality, and also to provide high-strength connection in thin panel applications. Now, the questions that are always here for my customers is, which of this technology is the best? If I had to pick only one, which one would that be? Would that be self-hinching, stud welding, riveting, or thread forming? Well, unfortunately, there is no ready-made answers to that question, and it strongly depends on your application. It has to be taken on the case-by-case basis. But to give some pointers, I have created a table here which gathers the most important properties that you have to look at when choosing a fasteners, along with the main technologies for sheet metal panels. So I've prepared a handout in the GoToWebinar platform that you can download and you can read or even share to your own team. Now I've prepared another poll to test your knowledge and see if you've remembered what we've discussed. So I'm going to start and launch the question for you to answer. Okay, so the question is now available on your screen. So which of these is not a riveting technology, not a category of rivet? Is it a tubular rivet, splits, pen, or blind? So I'm going to leave 15 seconds for you to answer. Okay, so I'm going to be closing the poll and answer that question. Okay. So obviously, the type of rivet that is not a riveting technology is pen rivet. Pen rivet does not even exist. What we've discussed is that 4 technologies exist in the market: solid, tubular, split, and blind rivet. And now the last question for this webinar is going to launch it. Okay, so now it's now available for you to answer. Is the following a requirement for drawn-out welding? It requires a capacitor to work, it requires a failure, or it must be automated. So which one of those 3 answer choice is the correct one? Okay, so I'm going to be closing the poll and answer that question. Okay, so as we've discussed, the only requirements from drawn-out welding is that it requires a ceramic failure here to contain the molten pool of weld. So this closes our webinar for today. If you have any questions, please feel free to either raise your hands or use the question box of the GoToWebinar platform. If you would like to ask question separately, you can use this invite on which you can find my email address, and you can send me an email directly. Alternatively, you can also contact our salespeople who have invited you for this webinar. Since we are already running out of time, I'm going to be closing this webinar. There will be a survey as soon as I close it for you to provide a feedback on what has been your experience with this webinar. So I would like to thank all of you for your time this afternoon, and thank you very much for your time. Thank you.